Maria made 2 batches of fruit punch. The table at the right shows how many quarts of juice she used for each batch. Write an equation that relates the proportional quantities. The constant of proportionality is, and the equation is. So that's everything we're going to do. So looking from here to here, we've got apple juice is X and grape juice is Y.
The opposite
and so,
it's half and half.
So they're having us do grape juice over apple juice. So that's going to be 8 over 5. So 5 is close to half of 8, but it's a little bit more. So if I take 8 divided by 5, I could leave it 8/5, but a lot of times we like to work with decimals. So 8 divided by 5 is 1.6. And then I could test the next one and just make sure I did it right. 16 divided by 10 is 1.6. So we're kind of verifying that this is proportional. And then we also have the constant of proportionality is 1.6. So my equation is y equals 1.6x. And that's how we do those. So that means to go from here to here, I'm going to take it times 1.6 every time. So I could add more columns to this, and I now know what to do. Okay. Guys, got it? 1 inch equals 2.54 approximately centimeters. How many centimeters long is an 18-inch ruler? So we're going to do a couple of things. So first of all, they have this nice little picture where they like zoomed in and then show it that it's 2.54. So a little bit more than 2.5 centimeters per inch. So let's make a table because I feel like that helps a lot of our brains. I'm going to make an XY table. And so this is going to be inches and this is going to be centimeters. So I know that 1 inch is 2.54 centimeters. So to go from inches to centimeters, I'm going to multiply by 2.54. So if I now put an 18-inch ruler there, I can tell, oh, I'm just going to take it times 2.54. So 18 times 2.54, cranking it out on my calculator, is 45.72. And then I can kind of fill in these blanks. So the centimeters is 2.54 times the inches. My equation is going to be y equals 2.54x. And then the ruler is 45.72 centimeters long. So in science, you'll do conversions. If you haven't already, you'll do them eventually, where you might be able to do 2 or 3 conversions at a time using a special table. This is just using 2 sets of information. We've got inches and centimeters and kind of figuring out that relationship. So this is your constant of proportionality. This is your equation. And then we answered the questions. So that way we know what to do when they ask for certain things. All right. I'm on the wrong one. A florist sells a dozen roses for $35.40. She sells individual roses for the same unit cost. So they're telling us it's not cheaper by the dozen. Write an equation to represent the relationship between the number of roses, X, and the total cost of the roses, Y, and then how much would 18 roses cost. So let's make a little table. So we're going to have X is roses. And I know that they do it sideways sometimes, but I still like doing it this way. And Y is going to be the cost in dollars. So a dozen roses is how many roses? How much is in a dozen? 12. So 12 roses is $35. Oops, I put the decimal too soon. $35.40. So what we might do is figure out what 1 rose is. So we can just divide these. So we're doing the y over x, so 35.40 divided by 12. And we could kind of estimate if that was 36, it'd be $3 a rose. So I can estimate that that's going to be a little bit less. So 290, I got 295. Did I do that right? Or were you just guessing? Well, you were close. So 2.95, so that's for 1 rose. And then if we want to do 18, I could just take 295 times 18. and I get $53.01. Tell me why it's wrong to leave that as 0.1 for money.
0. Because
Yeah, we need to have that 0 to show the 10 cents. And then I can just kind of circle that that's my answer and put a little dollar sign on it, $53.10. Now, some of you were using another strategy earlier on where you could go from 12 to 18 by realizing that they were adding half of 12 on, and you could do half of this and add, and that still works. But what they're doing on a lot of this is they're going to want us to write equations later on. So if they ask you to write the equation, let's just talk about that. It's going to be y equals, I'll make that a colon, and then whatever a rose costs, so $2.95 x. So this y is my output, my cost is $2.95 times x, which is the number of roses. So if I buy 3, I put 3 in, it'll tell me what I'm going to pay, et cetera, et cetera. Okay, so if they ask for an equation, that's what I would do. That doesn't look like a 53. Let me fix that really. It got kind of scribbled over. All right. Ilma is making a snack mix of pretzels and peanuts. For every batch, she uses 2 cups, this would say 2 cups of peanuts, and 3.5 cups of pretzels. Use the ratio of pretzels to peanuts to find the constant of proportionality. So when it says to use the ratio of pretzels to peanuts, that means you're going to take pretzels divided by peanuts. They're kind of telling you how you are going to divide that. And so pretzels are 3.5 cups. So 3.5 or 3.5 cups of pretzels for 2 cups of peanuts. So it's cups and cups. And we end up with 1.75 cups of pretzels per cup of peanuts. So it's just kind of getting us that ratio. And then it says how many cups of pretzels would she need if she used 11 cups of peanuts. So we can make a table, or we can just be like, okay, this is our ratio. Y equals 1.75x, where y is pretzels and x is peanuts. I know the peanuts, so I'm just going to take that times 11. And we end up with 19.25 cups of peanuts. So you can still do the table, and I think the table is valuable. It kind of helps us organize. But when we have this equation, sometimes we can just plug a number in and do some calculations too, which simplifies it a little bit. Okay, one more story problem, and then they're going to have us look at some equations. So balloon A is released 5 feet above the ground. Balloon B is released at ground level. Both balloons rise at a constant rate. Which situation can you represent using an equation of the form y equals kx? So let's just kind of go through these. So y over x is what we're doing. So I'd have 9 over 1, which is 9, and 13 over 2, which is not going to be 9. That's 6.5. And 17 over 3, also not going to be 9. So this one's going to be a big no, not proportional. Look at this one. I got 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. So this one I can tell is going to be proportional. It says, which situation can you represent using an equation of the form y equals kx? Explain. So we can say balloon B can be represented by y equals 4x because it is proportional. So if I'm going to do that proportional equation, it has to be proportional first. So the other one's equation is going to be a little bit different because it's not a direct relationship where I can take this times something to get this. It's going to be a different number every time I try to do it. Whereas here, I can just take everything times 4. Y equals 4 times x. So 3 times 4, 2 times 4, 1 times 4. So when we're looking at explaining these, we're going to use the words like proportional, ratio y over x, all of that good stuff. So now they're going to see if you can go backwards. So in our equations that we had before, the constant proportionality went with the x. Now they're going to give us equations, and we have to find the constant of proportionality. The constant of proportionality is the coefficient of the x, which is an old vocab word you may or may not remember. But it's the number in front of x. So for this one, it's 8.
Oh, that's easy.
For this one, it is 3/4. So what would it be for number 3?
2.5.
0.25. You're literally just snatching it out of that equation. It's next to the x. So it has to look like y equals kx, something x, if it's proportional. If they add or subtract other things, then it's not. So number 4 would work because I could have k equals 2, and it says which ones are proportional relationships. So this one I could say yes. Now number 5, they've got it times 3, but then they're also subtracting 8. Now subtracting 8 would mess it up and make it not proportional. On number 6, if I just had 0.2x, it would be okay. But they're adding 4 to it. And so that means that that is also not proportional. So what do you guys think about 7?
Yes.
Okay, what would be the constant of proportionality?
Oh,
X.
So what is implied? It would be 1. So it's 1. And so on that one, you might put k equals 1 underneath. So when I have x, that's always 1x.
I have one question.
Uh-huh.
What about if it's a negative? Does it still?
Negative can still work, sort of. Because usually when you have a negative that's bringing it down, it's going to start somewhere above the origin, where all of these would start at the origin if we were putting it on a graph, which is coming up later. So it would have to be a situation where everything coming out is negative for it to work. So sometimes is the short answer. All right, guys, we have 20 minutes exactly. So find your volume 1s, and you're going to do number 4, 7 and 8, 11, 12, 13, 14. And then if you have any time left over and you need to work on zerns that were due, you can work on that. If you have time left over and you're done with your zerns, then you get a little bit of relaxing time, I guess.
I'm gonna go to the bathroom.
Okay.
Bye.
Say always if you're having a problem you want to go, but you just always have to know that you're missing stuff.
I like it. You